Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Maths Chapter 1 Rational and Irrational Numbers. We will be discussing all the concepts and solve questions from exercise 1A. Hope you all are ready for the session. Let's start. Let us explore the different types of real numbers. From a very small classes, when we started to study alphabet, we have also started to count numbers. You remember when your teacher asked you to find how many chocolates you have, what you have done? You have started counting 1, 2, 3, 4, 5. You remember? So the numbers that we are using for counting, we are using them to count the numbers, okay? So these numbers are called natural numbers. 1, 2, 3, 4, etc. are the natural numbers up to infinity. And these natural numbers are represented using the letter N. When 0 is added to natural numbers, where you use 0, is 0 a number? 0 is the number. When this 0 is added to natural numbers, we call it whole number. So whole numbers represented by letter W is natural numbers including 0. 0 when added to natural numbers, you will be getting whole numbers. What about negative numbers? You have studied about negative numbers. So when you are measuring a temperature below the freezing point, it is negative. For example, negative 2 degrees Celsius. So this is a negative number, right? So here this negative sign shows the number is negative. So here when natural numbers, when you take the different natural numbers and put a negative sign with it, it becomes negative numbers. So negative numbers, the normal natural numbers, that is positive numbers, and 0 whole together we call it integers. So when you take, we know that all the natural numbers are whole numbers. But can you say that all whole numbers are natural numbers? No. Why? Because 0 is a whole number but not a natural numbers. When you take any natural numbers, for example 1 is a natural number, it is also a whole number. 2 is a natural number, it is also a whole number. But when it comes to the case of 0, 0 is a whole number but not a natural numbers. Again, we have a bigger set which is integers. It includes positive numbers, negative numbers and zeros. That is, all natural numbers are integers. All whole numbers are integers, but not all integers are whole numbers, because in integers we have negative numbers, but whole numbers is always positive and 0. So you cannot say 0 is either positive or negative. Okay, 0 doesn't have any sign. It is not neither positive nor negative. Okay, therefore all natural numbers are integers, all whole numbers are integers, but not all integers are whole numbers or all integers are natural numbers. The reverse is not possible. Okay, now what about other numbers? So integers we represented by letter Z or I. Okay, now for example, you take a pizza. You have 4 friends. Okay, including you, there are 5 members. You have to divide this pizza into 5 equal parts. Yes, what can be done? You will be dividing it such that each of them gets an equal share. 1, 2, 3, 4, 5. Okay, 5 equal pieces. So one person is getting 1/5 of it. Okay, 1/5 of the whole pizza is what a single person is getting. So here this 1/5, it is a fraction. Okay, this is a fraction. So when you measure the temperature, let's say the temperature is 30.2 degrees Celsius. Okay, here we have a point. When there is a point, we call it decimal. These are decimal numbers. Even if you take this 1/5, the fraction 1/5, it can be written as 0.2. So a fraction can be converted to decimal, and the decimal reverse is also possible. Decimal can be converted to fractions. Now these fractions and decimals cannot be included in this category. It is not a natural number. It's not a whole number. It's not an integer. When you take 2 integers, 0 and 1. 0 and 1 are 2 integers. Is there any number between 0 and 1? We can surely say that there is no natural number between 0 and 1. There is no whole number between 0 and 1. There is no integer between 0 and 1. But there are other numbers between 0 and 1. For example, when you take half, 1 by 2. When you check the number line, it is sure that 1 by 2 is a number that lies between 0 and 1. Also, we know that this 1 by 2 is neither a whole number nor an integer. Then what kind of number it is? These types of numbers, that is fractions and decimals, comes under the category of rational numbers. We represent rational numbers with the letter Q. Okay, so these fractions, these decimals can be included under the category of rational numbers. So when you take rational numbers, these rational numbers includes natural numbers, whole numbers, integers, decimals, fractions, etc. Understood? So all these are together called rational numbers. So when you consider the real numbers, there are two types of real numbers. That is, one is rational numbers and the numbers which are not rational are called irrational. So in detail, we'll be studying what are rational numbers and what are irrational numbers in class. Okay, rational numbers. So we understood what are rational numbers. Fractions and decimals can be included in rational numbers. We took the case of a pizza. 1 by 5th is the portion that each person gets. So this 1 by 5 is a rational number. So here we will understand how we can define rational numbers. So rational numbers are numbers of the form A by B. Okay, where A and B belongs to integers. A and B should be integers, and one more condition, that is B should never be equal to 0. So the numbers of the form A by B where A and B are integers and B not equal to 0 is called a rational number. So this rational number we represent by Q is equal to set of all A by B such that A comma B belongs to integers and B not equal to 0. Why B not equal to 0? What happens if B equal to 0? For example, 5 by 0. What is 5 by 0? Can you divide any number with 0? No. When you divide a number with 0, it means we are going to infinity. That is, you cannot divide, or it is not defined. The number is not defined. A number cannot exist. Okay. So what is 5 actually? 5 can be written in the form 5 by 1. Is it a rational number? Yes. Why? Because 5 and 1 are taking the position of A and B. Here A is equal to 5 and B is equal to 1. Both of these, 5 is a integer, 1 is also an integer. And the second condition, B not equal to 0. What is B? B is equal to 1 and it is not equal to 0. So both these conditions are satisfied. Therefore, 5 is a rational number. Okay. So if it is a single number, 2. 2 means it is 2 by 1. Okay. If there is no denominator given, it means it is divided by 1. Let's take another example. 3 by 4. 3 by 4 in decimal form will be equal to 0.75. Here A is equal to 3, B is equal to 4 and B is not equal to 0. So this is also a rational number. Another example. 0.25. 0.25 can be written as 25 divided by 100. 25 is 25 into 1. 25 into 1 and 100 is 25 into 4. So this fraction is 1 by 4. Okay. Here A is equal to 1, B is equal to 4 and B is not equal to 0. Therefore, this is also a rational number. Got the concept about rational number? Just you have to remember this. A by B form, A and B should be integers and B should never be equal to 0. Let's understand more about rational numbers. First, A by B is a rational number. First condition is B should not be equal to 0. The important condition is A and B should be integers. Then A and B are co-prime. What are co-prime numbers? So for example, if you are taking 2 and 3. Okay. Is there any common factors to these numbers? No, right? 2 into 1, this is 3 into 1. There is no common factors. Okay. So 2 and 3 we can call it as co-prime numbers. For example, if you are taking 5 and 10. Is there any number common in both? Here 5 can be written as 5 into 1 and 10 is 5 into 2, which means 5 is common to both these numbers. You can cancel this 5 and its fraction becomes 1 by 2. So these numbers are not co-prime, but these are co-prime because there is no common factor to them. Okay. 5 and 7. What about 5 and 7? 5 and 7 are also co-prime numbers. Then if you take 6 and 18. 6 is 6 into 1 and 18 is 6 into 3. Okay, 6 is common to both of these numbers, which means they are not co-prime. So understood? So here A and B are co-prime. What does it mean? It should be this type. That is, there should be no common factors. B is usually positive, whereas A may be positive, negative or 0. So how do we get it? For example, A by B form. If you are taking minus 5 by 3. Here A is negative and B is positive. If you take the reverse, that is 5 divided by minus 3. Usually when you have negative sign in the denominator, you won't keep it here. Okay, you can take that negative sign to the numerator. That is, you can write this as minus 5 by 3 or minus of 5 by 3. Both these are same. Okay, if there is a negative sign in the denominator, it can be taken to the numerator. That's why we say that B is usually positive. B cannot be 0, that is sure. And A can be anything. That is, it can be positive, negative or 0. If A is equal to 0, what does it mean? If A is equal to 0, the denominator can be any number. Okay, any number can be divided with 0. 0 by 1 or 0 by 2 or 0 by 3. Whatever it is not going to make any change. The answer will be 0. If you are dividing with any number, you are dividing 0, you will be getting the same answer. It will be 0. Okay. So the next point, second one, every integer, positive, negative or 0 and every decimal number is a rational number. That we have said, all the integers are included under the category of rational numbers. Not all rational numbers are natural numbers. Not all rational numbers are whole numbers. Not all rational numbers are integers. But all natural numbers comes under the category of rational numbers. All whole numbers comes under the category of rational numbers. All integers comes under the category of rational numbers, and the decimals and fractions also comes under the category of rational numbers. Okay. For example, if you take a positive number 2. 2 is a natural number, 2 is a whole number, 2 is an integer, 2 is also a rational number. If you take a negative number, minus 5 is an integer. It is not a natural number or a whole number, but this is an integer. Minus 5 is an integer. It is also a rational number. 0 is not a natural number. 0 is a whole number. 0 is an integer. 0 is also a rational number. If you take a fraction, 1 by 5. 1 by 5, it is not a whole number, it is not a natural number, it is not an integer, but it is a rational number. If you take a decimal, 0.15. 0.15, it is not a natural number, it is not a whole number, it is not an integer, but it is a rational number. Okay. So next point, corresponding to every rational number A by B, its negative rational number is minus A by B. That is very simple. If you take a rational number, 2 by 5, okay, and you take the negative of it, minus 2 by 5. So here negative, if 2 by 5 is a rational number, then minus 2 by 5 is also a rational number. Next, 7 by 3. 7 by 3, if 7 by 3 is a rational number, then negative of it, minus 7 by 3 is also a rational number. 2 by 7. If 2 by 7 is a rational number, then negative of it, minus 2 by 7 is also a rational number. Okay, if minus 3 by 2, if this is a negative number, negative of a negative number will be positive. If minus 3 by 2 is a rational number, negative of negative 3 by 2, which is 3 by 2 is also a rational number. Got it? Fourth point, a rational number A by B where A belongs to I or Z can be used to denote integers. B belongs to I and B not equal to 0 is positive if A and B both have the same sign. Okay, what does it mean? I have said you that 5 by 3 minus 5 by 3, 5 by minus 3. Here minus 5 by 3 and 5 by minus 3 are the same. Because if you have 5 by minus 3, you can write it as minus 5 by 3. Usually we don't keep it in the, keep the negative sign in the denominator. Okay, so here what they are saying, A by B is positive if A and B both have the same sign. Which means if you have 5 by 3 and minus 5 by minus 3. What is minus 5 by minus 3? Negative signs can be removed from the numerator and denominator. It will finally become 5 by 3. Okay, if there is positive sign in the numerator and positive sign in the denominator, or if negative in the numerator, negative in the denominator, in both these cases, you will be having a positive rational number. Okay. A rational number a by b is negative if a and b have opposite sign. That is 5 by minus 3. Okay. Here a is positive, b is negative. Therefore, the rational number is negative. The rational number is minus 5 by 3. Or if it is minus 2 by 9. Minus 2 by 9, numerator or a is negative and b is positive. This is again an example of a negative rational number. If both are of the same sign, either positive, both are positive or both are negative, then it is a positive rational number. If one, either the numerator or denominator is negative, then you will be getting a negative rational number. Two rational numbers a by b and c by d are equal if and only if a into d is equal to b into c. What does it mean? If you have two rational numbers a by b and c by d. Okay. When you take a into d and you multiply c and b. Okay. If this value of a into d is equal to the value of c into b, only then a by b and c by d will be equal. Just what is done here? You are doing cross multiplication. Okay, you are doing cross multiplication. For example, if you have 2 by 3 and 4 by 6. For example, if you have 2 by 3 and 4 by 6. Okay, here a is equal to 2, b is equal to 3, c is equal to 4, d is equal to 6. Okay, then what is a into d? A into d is 2 into 6, which is 12. C into b. C into b is 3 into 4, which is equal to 12. Which means a into d is equal to c into b. Therefore, a by b will be equal to c by d. When you just check these numbers, you will understand. Here there is a common factor. 4 by 3, 4 by 6. This is 2 into 2 by 3 into 2. 2 is a common factor which can be cancelled. Then you will be getting 2 by 3. Okay. For any two rational numbers a and b, a plus b by 2 is also a rational number which lies between a and b. Okay. So here if you have two rational numbers, for example, if you take 2 and 3. 2 and 3 are rational numbers. Okay. If 2 and 3 are rational number, then to find a rational number which lies between 2 and 3, what you have to do? You have to take a plus b divided by 2. Here a is equal to 2 and b is equal to 3. Okay. Therefore, 2 plus 3 divided by 2, which is 5 by 2. 5 by 2 is a fraction, or in the decimal form, you will be getting 2.5. 2.5. So, this 2.5, when you check the number line, you will understand that 2.5 is a number which lies between 2 and 3. Yes, equal distance from 2 and 3 lies before 3 and after 2. Okay, so we are getting a rational number which lies between 2 and 3. To find the rational number, you have to just take a plus b divided by 2. Let us take an example. Which of the rational numbers 3 by 5 and 5 by 7 is greater? Insert 3 rational numbers between 3 by 5 and 5 by 7 so that all the 5 numbers are in ascending order of their values. So, how to find if two rational numbers are given, which is greater? Okay, for that what you have to do is take the two rational numbers 3 by 5 and 5 by 7. Okay, we have to make their denominator same. For that we are going to take the LCM. Okay, here we know 5 is a prime number and 7 is also a prime number. If you have prime number, to get the LCM, what you have to do is you have to take the product of these two numbers. So, what is the LCM then? LCM will be equal to 5 into 7, which is 35. Okay. So, we are going to make the base of both these numbers or the denominator of both these numbers 35. Okay. 3 by 5. How do we get 35 in the denominator? What should be done? You have to multiply the denominator with 7. If 7 is multiplied to the denominator, 7 should also be multiplied to the numerator. Only then you will be getting 1. 7 by 7 is 1. So, this is possible. 3 into 7. What is 3 into 7? 21. Okay, so 21 by 35. 3 by 5 is equal to 21 divided by 35. Now take the second number, 5 by 7. Okay, we have to get in the denominator 35. What should be multiplied? You have to multiply the numerator and denominator with 5. 5 5s are 25. So 25 divided by 35 is what you are getting. So here 21 by 35 and 25 by 35. 5 by 7 is equal to 25 divided by 35. Okay, when you check these two numbers, here the denominator is same, 35. Now to get the greater one, you have to just compare the numerators. Here it is 21 and here it is 25. Which is greater? 25 is greater. Okay, therefore we can say that 25 by 35 is greater than 3 by 5, or 5 by 7 is greater than 3 by 5. So this is how you can find the greater number, by taking the LCM, making the denominator same. Okay, now what we have to do? We have to insert 3 rational numbers between 3 by 5 and 5 by 7, so that all the 5 numbers are in ascending order of their values. This is very easy. Here you have 21 divided by 35 and 25 divided by 35. Okay, keeping the denominator same. Put some values, that is between 21 and 25. You have 22, you have 23, you have 24. Okay, before that, let us use the method. If we take this as A and this as B, then to get the number which lies between, get a rational number which lies between A and B, what can be done? You have to find A plus B divided by 2. Here 21 by 35 plus 25 by 35 whole divided by 2, that is equal to 35. Denominator we have 2. Okay, 21 plus 25. What is 21 plus 25? You will be getting 46 by 35 divided by 2 by 1. Okay, now taking the reciprocal and multiplying, what do we get? 46 by 35 into 1 divided by 2, which is equal to 2 and 46 can be cancelled. We get 23. 23 divided by 35. Okay, so we have got a number 23 by 35 which lies between A and B. Okay, next A is equal to 21 by 35. Let us say C is equal to 23 by 35 and B is equal to 25 by 35. We need 3 numbers lying between A and B. Here we have got 1 number. To get the next rational number which lies between A and B, what can be done is take A and C. Okay, find what A plus C divided by 2 is. You will be getting a rational number because both these are rational number and it lies between A and C. If it lies between A and C, it means the number lies between A and B also. Okay, 21 divided by 35 plus 23 divided by 35 whole divided by 2, which is equal to 35. Denominator we have 2. 21 plus 23. What is 21 plus 23? You will be getting 44 divided by 35. Reciprocal multiplication, denominator 2, which is 22 by 35. Okay, 22 by 35. Okay. Similarly, if you take this C and B, find a number which lies between C and B. C and B both are rational numbers. You can find that is C plus B divided by 2. You can find a number which lies between C and B. And the number is 24 by 35. So if you put in the ascending order, you will be having 21 by 35 less than 22 by 35 less than 23 by 35 less than 24 by 35 less than 25 divided by 35. So this is the ascending order of arrangement of the numbers. So we have got 3 numbers which lies between 21 by 35 and 25 divided by 35. Okay. Here the question we have 21 by 35 is 3 by 5. 3 by 5 less than 22 by 35, 23 by 35 less than 24 by 35 less than, the number is 5 by 7. Okay. If you cancel, you will be getting this number. So this is the arrangement. Next, properties of rational numbers. First one, the sum of two or more rational numbers is always a rational number. If you take two rational numbers, 1 by 3 is a rational number, 2 by 3 is a rational number. When you take the sum, when you add it, you will be getting 3 by 3, which is equal to 1, which is again a rational number. So 1 by 3 is rational, 2 by 3 is rational. If you have more than two numbers, for example 1 by 4 plus 2 by 3 plus 1 by 2. Okay, three rational numbers when you add. Here 1 by 4, 2 by 3 and 1 by 2 are rational numbers. When you add, what do we get? Denominator. First you have to check, take the LCM of 4, 3, 2. Common we can take as 2. 2 is common in 4 and 2. So you will be getting 2 here, 3, 1. So these are primes. Okay. 2 into 3 into 1. 2 2s are 4, 4 3s are 12. So the denominator or the LCM is 12. Numerator, here we have 4. 4 into 3 is 12. So 3 into 1, 3. Plus 3 into 4 is 12. 4 into 2, 8. Plus 2 into 6 is 12. 12 into 1. 2 into 6 is 12. 6 into 1, 6. So you will be getting 17 divided by 12. 17 by 12 is again a rational number. Okay. Next, second one, similarly, the difference of two rational numbers is always a rational number. If you take two rational numbers, for example, 1 by 3 minus 1 by 2. Okay. We will be getting the denominator. Take the LCM. You get 6 here. Okay. 3 into 2 is 6. 2 into 3 is 6. Minus 1 by 6. This is a negative number. Negative numbers are also rational numbers. So minus 1 by 6, negative fraction, is again a rational number. The product of two or more rational numbers is always a rational number. If you take two rational numbers, for example, 1 by 5 into 1 by 2. When you take the product, you will be getting 1 by 10, which is again a rational number. Okay. Next point, the division of a rational number by a non-zero rational number is always a rational number. Why non-zero? Because if the denominator is 0, what happens? It is not a rational number, because we know that b can never be equal to 0 for it to be a rational number. So, other case, if you divide a rational number, for example, 5 is a rational number, dividing by a non-zero rational number 2, you will be getting 2.5, which is again a rational number. Clear? Next is the decimal representation of rational number. Terminating decimal, what does it mean? For example, if you take a number 1 by 2. What is 1 by 2? We need the decimal representation of 1 by 2. Dividing 1 with 2. How much do we get? 0. Here you will be putting a 0. 2 into 5 is 10. 0.5. 5 into 2, 10. Remainder 0. So the quotient is 0.5. 0.5. Next, if you take 1 by 4, what do we get? 1 by 4 will be equal to 0.25. If you take 1 by 8, this will be equal to 0.125. So, in all these numbers, you can understand that the decimal representation, numbers will finally stop. It is not continuing. So, this type here, if the decimals are stopping, then we call it as terminating decimals. Terminating means stop. Terminate means to stop. Okay. Here 1 by 4 is 0.25. It's not continuing. Here it is 125, 0.125. Again stopping. Okay. Now what is non-terminating decimals? If you take a number, for example, 3 by 7. Okay. If you take 3 by 7, let's divide 7. Okay. 0. Here you add a 0. 30. 7 into 4 is 28. You will be getting 4 here. Dividing. Now subtracting 28 from 30. You get 2. When you get 2, you will add a 0 again. 7 into 2 is 14. remainder will be equal to 6. Now 60, you get 8 times 56, 4 is the remainder, adding a 0, 5 times 35, 5, adding a 0, 7 times 49, 1, 0, 7, 1 time 7, 3. Okay, 30, 30, 4 times 28. Again the same thing will continue. 28 you will be getting 2 remainder, adding 0 you will be getting the next number 2. So this will be equal to 0.42857, 42857. This is going to continue. So you can see that it is not stopping. The division is going to continue. Okay. Now next is non-terminating recurring. So in this case, the quotient that we obtain is a non-terminating number. Non-terminating. Okay. Next, non-terminating recurring. For example, if you take the number, 4 by 9 dividing 4. Okay. You will be getting 0.40, 9 into 4, 36. 4 remainder, again 0, 9 into 4, 36. Here you have 4. Again taking the remainder, putting 0, 9 into 4, 36, 4. What is happening? It is continuing, right? 0.4444, etc. The number is not going to change. So this can be written as 0.4 bar. Okay, which means the number is not terminating, but the number is repeating. The same number is repeating. So this quotient is a non-terminating recurring. Recurring means repeating quotient. Clear? So this is what terminating decimal, non-terminating decimal and non-terminating recurring decimals are. Now let us take an example. Take a number 1 divided by 25. This can be written as 1 by 5 into 5 or 1 by 5 square. Okay. Next, 1 by 20. 1 by 20 can be written as 1 divided by 4 into 5 or 1 divided by 4 is 2 square. 2 square into 5. If you take another number, 1 by 40. 1 by 40 will be equal to 1 by 8 into 5. That is 1 divided by 8 is 2 cube. 2 cube into 5. Okay. In all these examples, you can see that the denominator can be expressed either as factors of 2 or as factors of 5. Okay. 5 square. Here if you write the factor of 2, you can write it as 2 raised to 0. 2 raised to 0 will be equal to 1. Okay. In all these cases, if you have a rational number, you need a term. If you need to find a term, if it is having a terminating decimal or not, what you have to do is you should take the denominator, try to express it in this form. Okay. Here the form is 2 raised to m into 5 raised to n. If you are able to express the denominator in 2 raised to m, 5 raised to n form, where m and n should be any whole number. It can be 0, it can be 1, it can be 2, anything. Okay. If m and n are whole numbers, then you will be getting a terminating decimal as the quotient. If the denominator of a rational number can be expressed as 2 raised to m into 5 raised to n, where m and n both are whole numbers, the rational number is convertible into a terminating decimal. Another example, 1 by 30. Okay, in 1 by 30, how can you write 1 by 30? 1 by 30 is 1 by 3 into 2 into 5. Okay, here you are having 3. Yes, 2 raised to 1, 5 raised to 1, that is okay, but you have 3 here. It is not able to express in the form 2 raised to m, 5 raised to n. Therefore, you won't be having a terminating decimal. Let's take an example. Without doing any actual division, find whether each of the following is a terminating decimal or not. First one, 17 divided by 50. Take the denominator 50. We know 50 is equal to 5 into 10 or 5 into 10 is 5 into 2. This can be written as 5 square into 2 raised to 1. Here m is equal to 1 and n is equal to 2. Both of these are whole numbers. It is able to write in the form 2 raised to m into 5 raised to n. Okay. Therefore, here we have terminating decimal. This is a terminating decimal. Next, second one, 7 divided by 8. 8 can be written as 2 cube. 2 cube into 5 raised to 0 because we need 1. Okay. Here m is equal to 3 and n is equal to 0. Therefore, we are having again a terminating decimal. Okay. Next, 23 divided by 72. How can you write 72? 72 is equal to 8 into 9. Okay. 8 is 2 cube and 9 is 3 square. If you take 5, you can put 5 raised to 0. But this 3 square we don't need. Since there is 3 square, this is not a terminating decimal. Non-terminating decimal. Understood how to find if it is a terminating decimal or not? Now let us solve problems from exercise 1A. Question 1. Is 0 a rational number? Can it be written in the form P by Q where P and Q are integers and Q not equal to 0? What is the answer? We have discussed this before. Is 0 a rational number? Can 0 be written in the form P by Q? 0 can be written as 0 by 1 or it can be written as 0 by 2, can be written as 0 by 3, 0 by 4, etc. Okay, all these values are equal to 0, which means 0 can be expressed in the form P by Q. First condition satisfied. Second condition, what is the second condition? P and Q should be integers. Here we have taken only integers in the denominator and numerator. Okay, 0 is an integer. Then Q not equal to 0, denominator is not 0. Here denominator is 1, here it is 2, here it is 3, here it is 4. So numerator can be 0, denominator cannot be 0. So what can we say? We can conclude that 0 is a rational number and can be expressed in the form P by Q where Q not equal to 0. Second problem, arrange minus 5 by 9, 7 by 12, minus 2 by 3 and 11 by 18 in the ascending order of their magnitude. Also find the difference between the largest and the smallest of these rational numbers. Express this difference as a decimal fraction correct to 1 decimal place. So the numbers are, we have 4 numbers, minus 5 by 9, 7 by 12, minus 2 by 3, 11 by 18. First we have to take the LCM. The numbers are the denominator 9, 12, 3, 18. So first, if you take 3, you will be getting denominator here 3. 3 into 4 is 12. 3 into 1, 18. 18 is 3 into 6. Okay. Again we can take 3, 1, 4, 1, 2. Next we can take 2. Then you will be getting 1, 2, 1, 1. So when you multiply this, here we have got prime. So by multiplying you will be getting the LCM. 3 3s are 9, 9 2s are 18, 18 2s are 36. The denominator should be 36. Okay. All the denominators should be taken as 36. What about numerator? Here to get 36, 9 into 4 will give you 36. So numerator also 4. Minus 5 into 4 minus 20. Okay. 12 into 3 is 36. So denominator 3, numerator 3. 7 into 3, 21. Next, here we have 36. 3 into 12 will give you 36. Numerator also 12. Minus 2 into 12 minus 24. 18. 18 into 2 is 36. Numerator and denominator 2. 11 into 2, 22. Okay. Now the denominator is same. Compare the numerator, which is the smallest value. Minus 24 divided by 36 less than. Next, minus 20 divided by 36 Next, 21 by 36, 22 by 36. Take the corresponding numbers. What is minus 24 by 36? Minus 24 by 36 is minus 2 divided by 3. Minus 2 by 3 less than. Minus 20 by 36 is minus 5 by 9. Minus 5 by 9 less than. 21 by 36 is 7 by 12 less than. 22 by 36 is 11 by 18. 11 by 18. So this is the ascending order. Next, we are asked to find the difference between the largest and the smallest of these rational numbers. Largest is 11 by 18 and smallest is minus 2 by 3. Okay. So largest 11 by 18 minus 2 by 3. Negative into negative is positive. This becomes 11 by 18 plus 2 by 3. What is LCM? 18 and 3. LCM is 18. Okay. 18 into 1 is 18. 1 into 11, 11. Plus 3 into 6 is 18. 6 into 2, 12. That is equal to 33 divided by 18. Okay. We need to find correct to one decimal place. So when you divide, here 33 divided by 18, we can simplify, this becomes 11 by 6. 11 by 6 is equal to 1 point. So when you divide, what do we get? 11 by 6. 1.6, remainder 5, 50. 50, how much do we get? We get 8. That is 48. Remainder 2. So you are asked to find only up to the first decimal place. So 1.8 is your answer. Clear? Problem 3, exercise 1A, question 5. Without doing any actual division, find which of the following rational numbers have terminating decimal representation. So here we have 4 rational numbers given. First one, 7 by 16. Take the denominator. 16 is the denominator. 16 can be written as 2 raised to 4. 2 2s are 4. 4 2s are 8. 8 2s are 16. 2 raised to 4 into 5 raised to 0. Okay. 2 raised to 4 into 5 raised to 0. Therefore, it can be expressed in the form 2 raised to m into 5 raised to n. Therefore, this is having a terminating decimal representation. Next, 23 by 125. Take 125. What is 125? 5 into 5, 25. 25 into 5, 125. Which is 5 cube. So, this can be written as 2 raised to 0 into 5 cube. Here, m is equal to 0 and n is equal to 3. This is again expressed in the form 2 raised to m into 5 raised to n. Therefore, here we are having a terminating decimal representation. Next, 17 by 40. Take 40. What is 40? 40 is 8 into 5. 8 is 2 cube into 5 raised to 1. M is equal to 3, n is equal to 1. Both of these are whole numbers. Here it can be expressed in the form 2 raised to m into 5 raised to n. Therefore, this is again having a terminating decimal representation. Next, 250. 123 divided by 250. How can you write 250? 250 is 25 into 10. 25 is 5 square and 10 is 5 into 2. This becomes equal to 5 cube into 2 raised to 1. M is equal to 1. N is equal to 3. Here again you are expressing in the form 2 raised to m into 5 raised to n, where m and n are whole numbers. Okay, so this is also having a terminating decimal representation. That's all for today. In today's class, we have discussed what are rational numbers, the form of rational numbers, properties of rational numbers, addition, subtraction, multiplication and division, how to find the greatest rational numbers and how to find rational numbers between any two rational numbers. Hope you all enjoyed the session. We have also solved problems from exercise 1A. There are a few more problems left. You can solve it on your own. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.